Hey there, this is part 2 of the Solving Polynomials and Rational Inequalities video. If you haven't seen the first one, I think it might be okay to jump into this one, but I recommend that you watch the first one. So here we want to solve this polynomial, so for things that are less than 0. So one of the first things is, for the steps, is we want to factor completely. So the first thing with anything that looks like this, or when we get to rational polynomials, rational expressions, we want to be able to factor completely. And then find the zeros of the polynomial and plot them on a number line. And the third step is plotting the zeros on the number line divides your number line into regions. So use test points to check each region. And then you're going to put everything into interval notation from there. So write the solution in interval notation. So in this case, looking at this fourth degree polynomial, I know that I want to factor it, but I have 1, 2, 3, 4, I have 5 terms, so I can't use factor by grouping. Factor by grouping usually works when you have 4 terms. So when it says factor completely, then what do? So this is when we want to use the rational root theorem and see if we have any rational roots. So the rational root theorem says that is the factors of the constant term divided by the factors of the leading coefficient. So the leading coefficient in this case is 1, and the constant term here is -4. So our possible roots, rational zeros, are plus or -4, essentially the factors of -4 divided by the factors of 1. So plus or -4, plus or -2, and plus or -1. And so we can go through all of those and check which one gives us a 0. Right, notice that I have, based on the Descartes rule of signs, there's 1 sign change, 2, there are 3 sign changes. So we have at most 3 rational zeros that are positive. So potentially 4, 2, and 1, positive 1 could be rational zeros. So before preparing this video, I went through +2, -2, -1, and +1, and turned out the +1 is a root, a rational zero. So I'm just going to go through the synthetic division for checking if 1 is a 0. So I take 1, right, and then we put the leading coefficients, all the coefficients of each term. I'm going to have 1, 3, -3, 3, and -4. So the fourth degree, third degree, second degree, first degree, and constant term. Then we bring down the leading coefficient, 1. So 1 times 1, we multiply. 1 times 1 is 1, and we add. So 3 plus 1 is 4. 4 times 1, now multiply the second one. So 4 times 1 is 4, and again we add. -3 plus 4 is 1. 1 times 1 is 1, and then we add again. So 3 plus 1 is 4, and then 4 times 1 is 4. So when I add -4 and 4, I get 0, which is what we want. That lets me know that it is a 0 because the remainder is 0. So therefore, I know since 1 is a 0, that means that x minus 1 is a factor. And then what we're left with is the coefficients of the quotient. So because this was a fourth degree and we divided by a linear, these are all the coefficients starting with a third degree polynomial. So this is a third degree polynomial. So that means that our original x to the fourth plus 3x cubed minus 3x squared plus 3x minus 4 factors into x minus 1 right, are 0. Since 1 is a 0, that means x minus 1 is a factor. And then my third degree polynomial from up here. So this is my third degree polynomial. And these are the coefficients. So it's going to be 1x cubed plus 4x squared plus 1x plus 4. So that's how that third degree polynomial gets written. And now we can factor it. Now notice that this one is 4 terms, so I can try factor by grouping. So we're going to factor this one by grouping. Or if you want to continue doing long division, right, that, like I said, when I did this in preparation for the video, I checked positive 2, negative 2, positive 1, and negative 1. So you could check positive 4 and negative 4 and see if any of those are zeros, and then that will give you the factors. But in this case, I did this one by grouping. So x cubed plus 4x squared plus x plus 4. I do it by grouping, taking groups of 2 at a time. So what do the first two have in common? They have an x squared. So I'm left with x plus 4. And the second group, they don't have anything in common. Well, they really have a 1 in common, right? Nothing in common means that the factor of each of those is a 1. So x plus 4. And now the x plus 4 is in common, so I do x plus 4, take it out, and you're left with x squared plus 4. So therefore, we can say this polynomial is completely factored into x minus 1, right? The factor that we got from the synthetic division times the new factors that we get from factor by grouping. So I have x plus 4, which means that negative 4 is a 0. Right, so if you had checked that by synthetic division, you would have seen that negative 4 is a 0, and then x squared plus 1. And just to remind ourselves, what was the inequality? X to the 4 less than 0. So that whole polynomial, we're solving the inequality less than 0. Now, does this one factor? So can we factor it some more? It's a quadratic, so we should check. But here we're looking for two numbers that add up to, that multiply to 1 and add up to 0, and that doesn't work. So no, it does not factor. This is what we call an irreducible. So no real zeros. Well, in this particular case, there's no real zeros because we would end up with x squared equals negative 1, and that can't happen. Just because it's irreducible doesn't mean it has no real zeros. It just means it's not a rational zero. Okay, so those don't factor. So now, is it completely factored? Let's go back to our steps. So we want to make sure it's completely factored. Yes, we have our two factors and an irreducible, meaning it does not factor anymore. And so now let's use test points to check each region. So we want to find our zeros and plot them on a number line, and then use test points to check each region. So our zeros are 1 and negative 4. And this one gives us no real zeros. So I don't need to check that, right? If you try to solve it, you get this x squared equals negative 1, which is not a real number because you will have x equals plus or minus the square root of negative 1, which is an imaginary number. So let's go to a number line and put in negative 4 and 1. So these are our zeros. So I'm going to put circles on them. Are they solid or open? Because it's just less than, then we'll leave them open, right? They're not included. So let's check test points in each region. And remember, we're testing that the product of all these things is less than 0. Less than 0 means negative. So I'm going to plug in my test points into these quantities. And I'm trying to see, is it positive or is it negative? So in the first region, let x equal negative 5. So plug it in. So negative 5 minus 1, negative 5 plus 4, and negative 5 squared plus 1. So negative 5 minus 1, that's negative. Negative 5 plus 4, that's negative. the negative 5 here is getting squared, so that's positive, plus 1 is positive. So a negative times a negative is positive, times a positive, we get positive, and we don't want that. Okay, we're looking for things that are less than 0. So less than 0 means we want the product to be negative. So let's check the next region. So, I didn't write the region for the first one, but so in negative 4 to 0, let x be, to 1. I didn't write the 1 there. So in negative 4 to 1, let x be 0. And so we're going to plug it into our product. So 0 minus 1, 0 plus 4, and 0 squared plus 1. So I get negative times a positive times a positive. And negative times a positive is negative times another positive stays negative. And we are looking for things that are negative, so that means we're going to shade this. So shade that. And then what happens on the other side from 1 to infinity? So in the interval 1 to infinity, pick something for x. Let x be something larger than 1. So 3, for example. It doesn't matter, right? As long as it's a representative from that region. So if I put in 3, so I'm going to have 3 minus 1, 3 plus 4, and 3 squared plus 1. Now everything here is going to be positive. 3 minus 1 is positive. So I get positive times positive times positive, so everything is positive. So I don't shade that because we're looking for things that are less than 0. So the product of these three quantities, once I plug in x, has to be a negative number. And so that only happens in between negative 4 and 1, not included. So our solution will be that x is in the interval negative 4, 1. Parentheses because they cannot be 0. Okay, so on the next video, I'm going to do one with rational inequalities.